Welcome guys back to Miss Karen's Math Corner. I certainly have enjoyed looking at your answers this week. I think the problem was a little bit harder, so I'm anxious to go over it with you. But first, of course, we need a math joke. And since I don't have any new ones, you have to have one of mine. So, what do you call a dude who loves math? An algebro. You get it? Pretty bad? Send me the jokes. Send me the jokes. Okay, so let's get right to the solution. All right, so here is our problem. Our first problem. All right, so the bulletin board. Help me. I'm going to make a geometry bulletin board of circles, triangles, and squares. I know that 20 shapes will fit across the board. 12 shapes will fit down the board. If I start in the left-hand corner with a circle, followed by a triangle, followed by a square, and repeat the pattern all the way around the board, how many of each shape will I need? Circle, triangle, square, circle, triangle, square. And my hint to you was to draw a picture. So, what did Miss Karen do? I drew a picture. Okay. We know that 20 shapes fit across and 12 shapes fit down, and we know the pattern is circle, triangle, square. So, I started up in the left-hand corner. I started with a circle, triangle, square, circle, triangle, square. I continued all the way over till I got 20. Okay? I ended here with the triangle. So my next is a square. But notice, this is the 20th shape across the top, but it is also the first shape coming down the right side. So here I go, triangle, square, circle, triangle, square, circle, all the way down. I get my 12 shapes all the way down, and the 12th shape is a circle. All right, there we go. Now, again, this is the 12th shape here on the side, but it is also the first shape along the bottom. So then I go circle, triangle, square, circle, triangle, square, continuing the pattern till I get to the 20 over here, which is a triangle. Again, that triangle is the last shape there on the bottom, but it's also a shape from along the side. So I get triangle, square, circle, all the way up. Now I have to figure out how many of each shape. Notice if I have 20 here and 20 here, and I count these, how many other ones did I need through here? Well, these I've already counted on the top and the bottom, so I really only had to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 extra shapes because I had 2 from the top and the bottom of the bulletin board. All right, so what was our question? Our question was how many of each shape? So what I did is I color-coded them. All the orange circles, I went all the way around, put dots in all my circles, and I counted them, and I got 20. In my triangles, I put blue dots. I went all the way around, and I had 20. What do you know? In my squares, I put red dots, went all the way around and counted them, and I got 20. So I had 20 circles, 20 triangles, and 20 squares. I had a total of 60 shapes, and each 20 of each of my different geometric shapes. Did you get the corner? Did you figure out that that also counted down here? That was a little hard. So let's try the second problem. Because in the second problem, if you remember, I'm making the same geometric border, but this time I'm going to start with a 4-sided figure, followed by a 5-sided figure, followed by a 6-sided figure, followed by a 7th, 8th, 9th, and 10th sided figure. Once I get to 10 sides, I'll repeat the pattern. I know that 20 shapes will fit across, 12 shapes will fit down, and I want to know how many of each shape I will need to surround the border. Now, before we start that, let's review our names because Miss Karen used the names to solve the problem. If you remember, a 4-sided was a quadrilateral, 5-sided was a pentagon, 6-sided was a hexagon, and 7-side, we're going to call it a septagon because it has this, heptagon is the same beginning letter as our hexagon. 8-sided, octagon, 9-sided, nonagon, and 10-sided decagon. So, this one looks a little bit different. Whoa! Okay, so what we know, the board has 20 shapes across, 12 shapes down, and the pattern is, remember, quad 4, pent 5, pentagon 5, hexagon 6, septagon 7, octagon 8, nonagon 9, and D for decagon. So, I started with the quadrilateral, Q, P, H, S, O, N, D. Then I repeated Q, P, H, S, O, N, D till I got all the way over to the 20th shape. The 20th shape was my nonagon. So then I started down, N, O, Q, P, H, S, all the way down till I get to the I got my 12th shape. Notice again, my last shape on the top row, the nonagon, is my first shape on the side. So I went all the way down. The H is the hexagon, is the last shape on the side, but it's also the first shape along the bottom. Hexagon, septagon, octagon, nonagon, decagon, I continue over. My last shape on this row was the Q at my quadrilateral. That is, counts here as the last shape, but it also counts as one of the shapes along the side. So I went Q, P, 8, Q, quadrilateral, pentagon, hexagon, septagon, all the way back up, and I ended with my septagon, okay? So I have 20 across, 12 down, but I really only needed 10 new shapes because these two were counted on the top and the bottom row, 20 across the bottom and 10 new shapes here because these were already counted, all right? So we notice what happens in the corner. This guy is double count, we can't double count him because he counts on the top and along the side. So we get to start counting. So I put quadrilateral and then I counted my Qs. I went all the way around, counted all the Qs, and I got 9. Then I counted the Ps, the pentagon. 1, 2, 3, 4, all the way around, and I got 9. Okay? Then I counted my hexagon. 1, 2, 3, 4, all the way around, I got 9. Then I counted my septagons. 1, 2, 3, 4, 5, all the way around, and I got 9. But watch what happens. octagon, 1, 2, 3, 4, 5, 6, 7, 8. I only have 8 octagons, 1 less. And my nonagons, again, 1, 2, 3. If I continue around, I only got 8 nonagons. Decagon, same thing, 1, 2, 3. All the way around, I got 8 decagons. Now, we knew from the problem before that we have a total of 60 polygons. So let's add it. Did we get 60 polygons? 9 and 9 and 9 and 9. Multiply 9 times 4, that's 36. 1, 2, 3 eighths. 8 times 3 is 24. And if we add 36 and 24, we get 60 polygons. So, did you get the answer to that one? That one was a little tough, wasn't it? But the key, I hope you saw, the key to this was drawing out showing all the work and drawing the figure. Because once I showed you all the way around, it was very, very easy to count how many of each shape. So I hope you had some fun solving this. I hope you have a great weekend, and tune in next Tuesday to see who our winner is. Have a great weekend, guys. Bye-bye.